Okay, today we're going to look at lesson 10, and your I can statement or learning objective is I can simplify and classify polynomials. So we are switching gears, and this is unit 5, polynomials. And I forgot to write that at the beginning, but we'll add it in now. So this is unit 5. It's all about polynomials. And we're going to start today by simplifying and classifying those polynomials. Because before we do anything with them, we have to know what they are and how they work. So that's where we're going to start. So today's notes are going to be a little bit different. You're going to see vocabulary and examples all mixed in together because this lesson isn't one that's easily separated into vocabulary terms and then practice. It's kind of all together. So just follow along with me, write down the terms, the practice problems, and then use this to work on your Math Excel work. As always, I'm going to go faster in the video than I would if we were in person, but you can pause and rewind as you need to, or you can rewatch, whatever you need to do. So keep that in mind, and we'll get started. Okay, so we'll start by talking about a polynomial. A polynomial is a monomial or sum of monomials. And I know that probably doesn't really explain much, and I hate when we use one term in the definition of another, but that's just how it is. So all of these are polynomials. A monomial is just one term. So like x, 4, x squared, those are monomials. Or you can have a sum of those. So 3x plus a negative 6, okay, or minus 6, that's a sum of monomials. Or 4x to the fourth minus 3x squared plus 6, that's a sum of monomials. So each of these is a polynomial. You've seen those. We've worked with them. The quadratics that we were talking about in our last unit, those are polynomials. So some of the stuff that we're talking about is going to be very, very similar, okay? We're just looking at some higher exponents. Okay, when we're talking about polynomials, when we refer to the term of a polynomial or the terms of a polynomial, they're separated by plus and minus signs. So like if you look at this one, 3x is a term, negative 6 is a term. Okay, and when we're talking about the terms of a polynomial, the exponent of each term is that term's degree. So like this term is x squared, so the degree is 2. Okay? If we look at this one, this term's exponent is 4, so this term has a degree of 4. This one has a degree of 2. This one has a degree of 0. So when you're looking at each term, you can pick out those individual degrees. Now, the highest exponent, and I use a squiggly line to emphasize the highest exponent among all the terms, is the degree of the polynomial. So we're going to use that degree or that highest exponent to classify our different polynomials. So when you're looking for the degree of the polynomial, make sure you're looking for the highest exponent of all the terms, okay? And we'll talk about the different names in a bit, okay? Next, I wanted to just remind you of this. I think we mentioned it back when we were talking about quadratics, but the term, when referring to the solutions, x-intercepts, roots, and zeros of a polynomial, those all kind of mean the same thing. Now, since we're talking about polynomials, we're going to refer to them as zeros more often than not, but all of these are basically the same thing, okay? They just have a different name depending on how, in what context you're referring to them. All right, so you do have a question in Math Excel today that asks, all real zeros of a polynomial show up as what on the graph? And so I wanted you to make the connection that if you have a real zero, and I think we mentioned this with the quadratics as well, if you have a real answer, a real solution, meaning it's a real number, not imaginary, then that corresponds to an x-intercept on the graph, okay? So the same is true here. If you have a real zero or real solution, it's corresponding to the x-intercept on the graph of that function. Okay, next we need to talk about the standard form of a polynomial. And we have to be specific here because we have a few different standard forms. The standard form of a polynomial refers to what you get when after all of your like terms are combined and your polynomial is written with the degrees in decreasing order. Okay, here is an example of a large polynomial in standard form. But what I want you to see is that it's written with the exponents of each term decreasing. So we start with 7, then have 6, 5, 4, 3, 2, 1, none. Okay? So if you're asked to put a polynomial in standard form, you simplify it first, see if there's anything that you can combine or simplify, and then you write the terms with the degrees descending. So you start with the biggest degree and go down. Now, something I do want you to notice, this first coefficient is called your leading coefficient. Okay, we referred to it as A with our quadratics because we had ax squared plus bx plus c, so that A was our leading coefficient. We're going to refer to that later, so you need to know that that first coefficient, when it's in standard form, is your leading coefficient. Now, we'll practice writing some polynomials in standard form. Okay, here are 4 examples. If you want to, pause the video, write these down, give them a try, and then come back and check them with me. Okay, so number 1, we have 3x squared minus 6 plus 2x. So we find our highest. Well, first, is there anything that we can combine? No. So we find our highest exponent, which is 2. So that's where we're going to start. So 3x squared. All right, so that one's out of the way. Now we have negative 6 and 2x. So if we look up here, the thing with the x comes first because that's a degree of 1. So we'll do plus 2x. And then we have a minus 6 at the end. Okay, and what I want you to notice is when we rewrite those, you take the sign of that coefficient or that constant along with it as you move. Okay, number 2, 3 minus 4x squared plus 5x cubed plus 3x squared. Is there anything that we can combine? Yeah, we can combine negative 4x squared and 3x squared, so we'll do that in just a minute. What's my highest exponent? The 3, so we have 5x cubed. Then squared is our next one, so 2. So negative 4 plus 3 is negative 1. So negative x squared. That takes care of those. And then we just have a positive 3 to tag on the end. So our constants or our numbers that are by themselves always are at the very, very end. Number 3, we have 5x to the 4th minus 9x to the 4th plus x to the 4th. We can combine all of those because they have the same exponent. So 5 minus 9 is negative 4. Plus 1 is negative 3, so we have negative 3x to the 4th. Now, this one's a little bit different. It's not ready for me to put in standard form. I'm going to have to simplify first. So first, I'm going to look at the 2 factors at the beginning. I'm going to do my double distributive property. And I'm going to have x squared minus 6x plus 2x minus 12. I'll combine that and get x squared minus 4x minus 12. All right, then I need to multiply by x squared plus 4. Sorry. And I know that this is a little extra work, but it'll be okay. So we have x squared times x squared is x to the 4th. X squared times 4 is 4x squared. And then negative 4x times x squared is negative 4x cubed. And negative 4x times 4 is negative 16x. Negative 12 times x squared is negative 12x squared. And then negative 12 times 4 is negative 48. And so now you can see I do have some like terms. And I can simplify those. And let me double check real quick. Okay, so our largest exponent is 4. So, and there's just one of them, so we start with x to the 4th. Our next smallest is negative 4x cubed. And then I have x squared, so I have 4x squared and negative 12x squared. That gives me negative 8x squared. I have a negative 16x and a negative 48. All right, so we simplified that one and put it in standard form. Okay, so I don't know that if you have any that complex in your assignment, but you know how to do them regardless. So check, see if you can simplify, put them in standard form. Okay, now we're going to talk about how to classify polynomials. So they can be classified by degrees and number of terms, or this should say by degree, not degrees, because a polynomial only has one overall degree. Sorry about that. So here are two little lists. So for the degrees, you have 0, 1, 2, 3, 4, 5, and then 6 plus. So if you have a degree of 0, it's a constant. That's just a plain number. If you have a 1, it's linear. So like 3x plus 6. The highest exponent is 1. It's on that 3x, so it's linear. The highest exponent of 2 is quadratic. We just spent a whole unit talking about quadratic, so you should know that. 3 is cubic, if you think cubed, okay? Cube has 3 dimensions. That might be helpful. 4 is quartic, 4 quarts in a gallon, 4 quarters in a dollar. And then 5 is quintic. You can think quintuples. I don't know. But 5 is quintic. And then for 6 and on, we don't have special names. We just say 6th degree, 7th degree, 8th degree, etc. Okay? You can also classify the polynomial by number of terms. So, and that's how many pieces or how many parts of the polynomial there are. So if there's just one, it's a monomial. Mono is the prefix for 1. 2 is binomial, 3 is trinomial, and if you have 4 or more, we just say it's a polynomial with blank terms. So polynomial with 4 terms, polynomial with 5 terms, with 6 terms, etc. Now, I'll show you some examples of how you would find the classifications and write them out. Okay, here are 5 examples. I encourage you to pause the video, write these down, give them a try to classify them, see what you think, and then check your answers with me. Okay, so number 1, we have 4x plus 2. So the highest, it's in order, so I know I can start here at the beginning. The highest exponent is a 1, so that is a linear, and it has 2 terms, 1, 2, so that's a linear binomial. Okay. Number 2, it's in order. Our highest exponent is 2, so that's a quadratic. And it has 3 pieces or 3 terms, 1, 2, 3. So it's a quadratic trinomial. That's what we worked with a lot in our last unit. All right, number 3, let's see. It is in order. Our highest exponent is 4, so it's quartic. And it has 1, 2, 3 terms, so that's a trinomial. Okay, this one, if I just look here at the beginning, it's 5x, so that would be a 1, but is this in order? No. So you could put it in order first, or we can go through and we can look for the highest exponent, which is a 4, okay? And so it's quartic. And 1, 2, 3, 4, 5. So it's a quartic polynomial with 5 terms. Okay, and then last we have 8, so that's an 8th degree, and we have 1 term, so that's a monomial. Okay, so you can mix and match. You can make all kinds of different polynomials with your different degrees, different number of terms, but that's basically how you're going to identify them. So in your math Excel work, I think that you have some problems where you're going to have to put your polynomial in order or in standard form and then classify it. Some of them are just going to have you classify, but either way, you should be able to do it because we've practiced writing them in standard form, and now we've practiced classifying them. Okay. The next things we're going to talk about are multiplicity and end behavior of our polynomial functions. And they go together. They are very similar in their definitions and how you're going to recognize them. But we're going to talk about one at a time. So first we have the multiplicity. The multiplicity of a polynomial function is how the function graph behaves at the zeros or the x-intercepts. So when you find the zeros of a polynomial, how does the graph react? When you draw it out, or when you look at it in the calculator, how is the line behaving at those points? Okay, So if you have an odd degree of the polynomial, so your degree is like 1, 3, 5, 7, 9, so on and so forth, then the graph is going to pass through that intercept. So here's an example. So if we look at y equals x, then our graph is just a straight line. And so if we look at that parent function, the intercept is 0, and so it passes right through there. Okay, we can do the same with the parent function of x cubed. So the parent function of x cubed is something like this. Okay, so again, it passes through that intercept. All right, if it's an even degree, it bounces back or turns around. So if we look at the parent function y equals x squared, we know that's a quadratic function, and it just is this nice U shape. So it hits that point and turns around. Okay. We can also look at the parent function of y equals x to the fourth. It's very, very similar. It's just a flatter U. And again, it hits that x-intercept and bounces back. So if it's odd, it passes through. If it's even, it bounces or turns. And I think you have one question about that in your Math Excel work. You're going to have to, it's going to say if R is an x-intercept of an odd degree, and you choose passes through, and then it'll have another statement and it says even, and you will choose, I think it's turns is the correct term that it has in Math Excel. But you just have one question about this today. We'll talk more about it a little bit later, but I'll kind of show you what it would look like. So let me get a Post-it note here and I'll show you. Okay, so say I factored out this polynomial and I have x minus 2 cubed, and x plus 3 squared. So if I solve those, here my x would be 0, and that has a multiplicity of 1. Okay, it's odd, so that means it's going to pass through. Here, 2 has a multiplicity of 3, so it's odd. So over here at x equals 2, that means that it's also going to pass through. And then at 3, it's going to, or negative 3, it's a 2, so it's going to bounce. Okay, so my overall degree is 6. So that means that both of my ends are going to go up, and we'll talk about end behavior in a little bit. So if this bounces, then it'll bounce here. It goes through this point, so it might look like that. And then it's going to pass through this one as well. So my graph could look something like that. And this is just a rough sketch. Like, it's not anything perfect by any means. And I shouldn't have written X there. So we'll talk about end behavior, but because our overall degree is 6, that means both of our ends are going up. Okay. And if you solve each of those, the 0, it's odd, so it goes through. The 2 is odd, so it goes through. The negative 3 is even, so it bounces. Okay, and that's just showing you kind of what the multiplicity does. We'll talk more about it later, but this is just a quick little introduction. And so that's what it's talking about. When you see that word multiplicity and turns or passes, this is what it's referring to. Okay, so last we're going to talk about the end behavior of polynomial functions. So again, this is when you graph it, what's it going to look like? If your polynomial has an even degree, then your ends are going to go in the same direction. So if you think about a polynomial, or not a polynomial, a quadratic, a parabola, then that might help you. So for example, so y equals x squared, you have a U shape. So the ends are going in the same direction. An odd degree, ends go in opposite directions. So you can think about y equals x. That's just a straight line. So here, both ends are going up. Here, one is going up and one's going down. Okay? And so we're going to look at that. You're going to have to decide how the ends are going to behave. You're going to have to decide what the end behavior of a polynomial function is just by looking at the equation or the expression or the function, okay? And I'm going to show you how to do that. It's really easy. You just have to remember, even, they're in the same direction, odd, they're opposites, and we always read our graphs from left to right, and if you do that, you can think of it as slope, okay? That's going to help you when our leading coefficients are positive or negative, but I'll show you what I mean. Okay, so we're making a little chart. So if your degree is even and your leading coefficient is positive, your ends are going to go up, okay? Just like before with our quadratics, when A was positive, your parabola opened up, okay? The same is true with our polynomials. If that leading coefficient is positive and your degree is even, your ends are pointing up, okay? And these are just rough little sketches. Don't ask me to give you the equation for this right now. I just wanted you to see the end behavior. Okay, so the opposite is true. If your degree is even, but your leading coefficient is negative, or that front coefficient is negative, you're opening down. Okay, so you're going to have some questions that have you just look at the polynomial and decide what's happening at the ends. So you have to know those two things. You have to know if the degree is even or odd, and if your leading coefficient is positive or negative, okay? And if it helps, you can think back to your quadratics that we talked about in the last unit. Okay, I went ahead and I went over these with my other color just to make them stand out a little bit more. So if your degree is odd and your leading coefficient is positive, one way you can think about it is like its slope. So you're going up. As you go to the right, you're going up, okay? So it's slanting up toward the right, okay? You notice the ends are going in opposite directions, okay? There's some different examples. If your degree is odd and your leading coefficient is negative, or your slope is negative, you're going down to the right, okay? So that could help you. That might make it a little bit easier if you think about it as slope, positive or negative, okay? And that's easier with the odds because we're used to that. Now, one thing that I will mention, in Math Excel, at least one problem talks about moving up to the right and down to the left, or up to the right and up to the left. And so on those questions where it talks about it a little bit differently, you might want to just sketch out a picture and think about how it's moving. So like if I was looking at this one, I would say it goes up to the right and up to the left, okay? This one's down to the right and down to the left. This one's up to the right, down to the left, and so on and so forth. But make sure you read the wording on those when it's asking you for the end behavior. Just make sure you think about it. If you need to sketch out a little picture, you can. It doesn't matter what's going on in the middle as long as you do your end behavior. If we were in person and I asked you for the end behavior of a polynomial, you could even draw the arrows, and I would be okay with that. Math Excel won't let you just type in the arrows, though, so you've got to be a little more specific. But I'll show you an example of what you're going to do. Okay, so I'm just doing two examples really quick. So my first one is negative 6x cubed plus 2x. So my degree is odd, and my leading coefficient is negative. So odd means they're going in opposite directions. So one's going up and one's going down. And if it's negative, that means it's going to be something like this. Okay? So I would say it's up. My ends are going opposite directions. So your question could have that as an option. Or it could say up to the left, down to the right. Okay? Number 2, we have 4x squared minus 6x plus 8. So our degree is even. So that means our arrows are going in the same direction. They're both going up or both going down. Our leading coefficient is positive, so that means they're going to go up. So both ends are going up. It doesn't matter what they're doing in the middle, what the graph's doing in the middle. And so you could say up to the left, up to the right. Both ends go in the same direction. Both ends go up. Lots of different ways to describe that. But the main thing is that you know and you can visualize what it's going to be. Okay. Now, I feel like I've given you a ton of information, a ton of different vocabulary terms, and maybe a lot of stuff to think about. But I think that you guys will be fine. use this video to help you in your Math Excel work. And as always, if you have any questions about anything or need any help, or if you think I didn't explain something well and you want me to explain it again, please, please let me know. I would be happy to do that for you. It's been a long time since I've taught this, and I've never taught it virtually. So if you need help with something or you need me to re-explain, I would be more than happy to do so. You just have to let me know, okay? If you need me, I'm here. Hop back in the Google Meet, shoot me an email, hit Ask My Instructor, whatever you need to do. But have a great rest of the day.